The target learning objective for this lesson is why does the moon show phases? In this lesson, we're going to discuss the moon's motion, why the moon shows phases, and what are the phases of the moon, and how do we figure out the phases of the moon based on where the moon is in the night sky. So what are the motions of the moon? So the moon rotates once in 27.3 days. It also revolves once in 27.3 days. So the moon's period of revolution and rotation are the same. So we always see the same side of the moon from Earth. So on our reference table, the bottom on page 15 on the solar system data chart, the bottom of that chart has all the information about the moon. We have the mean distance from the sun, the period of revolution, period of rotation, eccentricity, equatorial diameter, mass compared to Earth, and we have its density. So anytime we're asked about the moon, sometimes we can look back on page 15 to get our information. So why does the moon really rotate? We're going to watch a little video to show if the moon really rotates.
The moon always face the Earth. It appears as if the moon does not rotate on its axis. Welcome to Moo Math and Science and the moon's rotation in orbit. The moon orbits the Earth once every 27.32 days. It also takes roughly 27 days for the moon to rotate once on its axis. In other words, it rotates once on its axis in the same time it takes to orbit the Earth once. As a result, the moon does not seem to be spinning, but appears from Earth to be almost perfectly still. Let's see what this looks like. Notice as the moon orbits the Earth, even though the moon is rotating, the same side of the moon is always facing the Earth. This side of the moon facing the Earth is called the near side. The side which always faces away is called the far side. Compare this to the moon if it rotated twice as fast, or once every roughly 13 and a half days. If the moon rotated more quickly, we would see the entire moon. The moon's orbit is an ellipse and is tilted by 5.15 degrees. The moon's distance varies from 7% less than average at the perigee, when the moon is closest to the Earth, to 6% more than average at the apogee, when the moon is furthest from the Earth. The moon travels faster across the sky at the perigee and slower at the apogee. When the moon is closer, it looks bigger, and when the moon is further away, it looks smaller. If you'd like to know more about the moon's orbit and rotation,
so that is why we only see the same side of the moon, because it takes the same amount of time for the moon to make one rotation as it does revolution. We're only going to see one side of the moon. So like the video said, if the moon were to rotate faster, we would see different sides, but because the moon's rotation is equal to its revolution is why we only see the near side of the moon and we never see the far side of the moon. Now we're going to discuss what causes us to see phases. So what causes the different phases of the moon? As the moon revolves around Earth, we see different amounts of sunlight that is reflected off the moon. So although it takes 27.3 days for the moon to revolve around Earth, it's going to take 29.5 days for the moon to complete one set of phases. And the reason for that is because as the moon is revolving around Earth, we are also revolving around the sun. So it takes the moon a couple days to catch up with the Earth and be in that right position to go through all the phases, okay? So a synodic month is the period of time it takes for the moon to go through the phases. So you can remember this, the month, if you put another O in it, month, it takes the moon about a month to go through all the phases, about 29.5 days. And then a sidereal month is its actual rotation and revolution. A sidereal month is going to be 27.3 days because that's how long it takes the moon to just revolve around Earth. So 29.5 days for it to go through all the phases, 27.3 days for it to revolve around Earth. So now we're going to discuss how to figure out what phase of the moon it's going to be. So this diagram you will often see. The sun sometimes changes position. Sometimes the sun is over here. Sometimes the sun can be above, below, or to the left. In this picture, the sun is to the left. So notice that all the moons are shaded in, dark on the right and light on the left side. And that's because the sun is located here. So the sun is lighting up this side of the moon. We are on Earth. So because of this is a bird's eye view. We're only going to see parts of the moon, okay? So if I were in this position on Earth, I'll just draw a little stick figure. I'm only seeing the dark side of the moon. This whole back side here, I'm not seeing at all, okay? That whole back side, I'm not seeing. So this entire back side, I don't see. So on Earth, I would see a new moon. So during a new moon phase, you would not see it at night, but sometimes you could see the new moon during the day. That's when you would see the moon during the daytime, but during a new moon phase, you would not see it at night because the sun is not going to reflect off the moon at a new moon phase. The next phase is a waxing crescent. So it's when it's lit up on the right side, that's waxing because it's going to get bigger. If we have a diagram, we would shade this part that we would not see on Earth. So it would be all of this side. And if I was located on Earth looking at the moon, I would only see this little portion lit up. So that's why we would see this, a crescent, because it's less than 50% lit up. And that is called a waxing crescent. So what that would look like is this, okay? So only this little portion is lit up, and this is how it would look like in real life. The next phase would be the first quarter. So you wouldn't see this whole backside. Okay, so you would shade that in. You looking from Earth, you would see that it was half lit up, half dark. So that would be the first quarter. Notice that the right side is still lit up, and now we're seeing more of the moon. So what that would look like would be like this. We have the moon half lit up, and this is what it would look like in real life. That is called the first quarter. The next phase is called the waxing gibbous. So now we wouldn't see this whole backside, so I've just shaded this little portion. And if you were located on Earth looking at the moon, you'd see that 3/4 of the moon is lit up and only a little part is shaded in. So this section right here actually should be shaded in. It's hard to do this on here, but this part would be shaded in, and you would see about almost a full moon, but only 3/4 the way filled in. So what that would look like is a waxing gibbous. Notice that only the left side is shaded in and the right side is completely lit up, okay? And this is what it would look like in real life. It's still waxing because the right side is lit up and it's getting bigger. After the waxing gibbous, we have the full moon. So this whole side that's dark, we don't see because we're located on Earth, okay? Full moon you would see right above you at midnight because we're right in the middle of night right here. So this would be full moon and it would be completely lit up. So what that would look like is you wouldn't shade it in at all, and this is what it would look like at night, completely lit up. After we have the full moon, we get into the waning phases. So because it's full, the first phase is going to be the waning gibbous. So again, I'm going to shade the back side of the moon. I'm located on Earth, so I'm going to see that it's 3/4 of the way lit up on the left side. So this side that's like in dotted, that's all dark, and we have the left side mostly lit up. So what that would look like is here, we have our waning gibbous, the left side's lit up, and it's going to look like this. So now that it's waning, we know that it's getting smaller. So after the waning gibbous, now we have the third quarter. So we would shade the backside of the moon. We're looking from Earth and we see that it's half lit up, half not. The left side's lit up, so now we know that we're in the third quarter. And then finally, we have the waning crescent. So this entire side again is going to be shaded because we're not going to see this side. We're located on Earth, so we are going to look and see only a small portion on the left lit up. So that's going to be our waning crescent. And that would look like this. So the left side, and then it goes through the phases again. So again, it takes 29.5 days to go through all the phases, and it takes 27.3 days for the moon to revolve around Earth. Notice that the moon also revolves around Earth counterclockwise, just as we revolve around the sun counterclockwise.